Hello, this is Sky speaking. In this section, I will introduce two commonly used statements in Verilog. One is if-else, and the other is case. Please see the simple code here and take several seconds to read it and try to understand the function of this code. And can you draw the block diagram of this code segment? Yeah, the function is simple. It will select different value and assign to the out according to the value of select. Yes. This is something perfect match the function of a mux in our digital circuit. So the block diagram is something like that. This is a mux. When cell is 1, it will mux the value to the out. Okay, when it's 0, it will mux this value to the out. And for the same function, you can use if-else statement, and you can use continuous assignment. Use the conditional operator. Yes, use the conditional operator to make the same function. And there is some synthesis coding rules for you. You have to follow this coding rule if you want to write something for synthesis. That is to make a combination logic for this segment. If you want to make some combination logic, the out must be assigned once at each trigger of this block. That is, there must be the else branch for each if statement. So for sensible code, you can't omit this part. Okay, you can't only write if cell d out equal to 2 and omit this line. This will cause problem and synthesis. And this is legal for simulation. Okay. From syntax, it's okay, it can simulate, but for synthesis, this will cause problem. The problem here is it will generate latch. Okay, you can try to understand if you omit this line. When the out changes, it will trigger this always block. Then, if cell is 0, then the out will not assign any value. Yes, that means for this trigger, the d out should keep its last value. Yes. So combination logic doesn't have the function of keep last value. It must use some cells that can store data. So latch will be used here. Okay, that's why you must have a else branch for each statement, for each if statement, or there will be synthesis problem. Okay. And for if-else statement, it has priority. The upper statement has higher priority. Okay, this line has higher priority than this line. So you can pair it with else if, many else if, then followed by a else. Okay, take several seconds to read this code segment and try to draw a block diagram for this code segment. The function of this code segment is, according to the value of D in, it will select different data to D out. So you need to remember this line has a higher priority. If it's 1, okay, if it's 2, if this statement is 2, this line will be executed and all the other lines will not execute. Yes. So if this is not true and this is true, then this line will be not executed and this line will be executed and these lines will not execute. So from this code segment, you can understand the mean of priority. So how about the block diagram for this code segment? Okay, it's something like that. You can check it with the code. If this is 1, data will be marked. This data will be marked. If it's 0, 0. So it will choose this line. Okay, and which data will be passed to here? It will depend on the value of bit 1 and bit 0. Yes. Okay, try to match the block diagram with RTL code. This is called consistency between RTL code and block diagram. Yeah, after this section, you need to have the ability of consistency between RTL code and block diagram. That is, give you the block diagram, you can write the RTL code for this block diagram. Or give you the RTL code, you can draw the block diagram for this RTL code. Okay, let's say the case statement. Okay, for this slide, you just focus on the case statement. This is something the same as switch statement in C language. Yes. The syntax, the keyword is case and case. Then you give an expression here, and these are the match items. These are the match items. You list each match item here. If either one of the item match, it will execute the statements after it. So if this one match, that is if D equal to 1, so this item will match and D out will be assigned to 2. Okay, can you draw the block diagram for this code segment? Okay, you can pause the video. Here is my answer. Yes. Actually, this is 8 to 1. Yes, 8 to 1 marks. You can make it by parallel use of 4 to 1 marks. Yes, 4 to 1 marks. 4 to 1. Then collect them up. Use 2 to 1 marks. Then make the 8 to 1 marks. This is something like we have said the binary tree architecture. Yes, binary tree architecture in the part 1 of this course. Tree architecture. You can have more depths of the tree. Yes. Okay, please note the collection of D in. Yeah. Why this is the bit 2 of D in? You can try to understand it as you can divide. Yes, you can divide them into groups. So you can say that for the first group, bit 2 of D in is 0, and for the second group, yes. So this equal to the first group, and this equal to the second group. Yes. And for each group, bit 1 down to 0 is count from 0 to 3. 0 to 3. Yes, 0 to 3. Okay, for 4 to 1 marks, you can use 2 to 1 marks to make it. Yes, this will be something like that. Yes. So how to collect the select signal? How to collect the select signal? Yeah, this should be bit 0. This should be bit 1. Yes. Yes. Okay. Okay, there is something you have to note for the case statement. From this figure, from this block diagram, you may think this execution of the case statement is parallel. Yes, parallel. The path is parallel, but actually, from the syntax of Verilog, the execution of this statement, you can say the compare of the match item isn't parallel. They have priority. Okay, the upper match item has higher priority. So it will match from the view of Verilog syntax. It will match from the first line. You can say from the upper line of the match item. It will compare the value of this item with D in first. If it match, it will execute this line and break. You can break the whole statement. Okay. So all of these lines will not be executed in this case. So this is something like you have write a break statement after this statement, like the C code. But in Verilog, you don't need to write the break statement. Okay, it's default here. The Verilog syntax will think there is always a break after until the end of each statement. So if this item doesn't match, then it will use the second item to compare with D. If it matches, it will execute this statement here and break the whole catch statement. So from the view of Verilog syntax, the compare of match item is prioritized. Okay, so you have to note that. Why? So why the synthesis tool can translate, or you can say can synthesize this code to the parallel compare architecture? Why? This is because if the tool can infer there is one and only one item can match at each time, then the tool can use parallel mux architecture to implement the code. This will shorten the pass delay. For example, for this code segment, the synthesizer tool can infer there is one and only one item can match at each time. Yes. D is a 3-bit signal. We have listed all the possible values here, and it can match one and only one for this code. Yes. So if this case is true, the synthesis tool can translate the case statement to parallel architecture. If not, it will translate to some architecture like that, the priority mux. This is the upper match item with higher priority. This is the lower match item with lower priority. Okay. Can you find some? Can you write an example that the synthesis tool can't infer there is one and only one item can match? Can you give an example of that? Yeah. Please think about it. Okay, let me give an example. So we have declared some signal here. You can use the din. This is the same mux case statement. Okay. The difference is you can use constant here. You can also mux variable. Okay. You can also mux variable signal to the diout. Okay. Let me give you an example. If we write as okay. If you give some variable signal here and the match item, so for this code, the tool can't infer there is one and only one item can match. For example, if A0, the bit 2 or bit 2 down to 0 of A0 is 0, okay, is 0, and D is 0, so there will be two items will match for each time. Yes. So this will take higher priority. If this case, the output value will be be 1, not 80. And if A0 is equal to 0, okay, and D in is equal to 7, that is 111 in binary. So there is no item will match for this case. Yes? Yes. Okay. So this is an example. Okay, this example show you many things. You can put signal here in the right hand, and you can put signal in the match item. Yes. Okay. And there is also the synthesis coding rule. To make a combination logic, you must make sure D out must be assigned once at each trigger of this block. Okay. So to make this true, you have to list all the possible values of D in. Yes, you have list all the possible values of D in here. Or you can write a default statement. You can write a default branch. For example, for this case, do you think this code match this requirement or not? Yeah, for this code it doesn't match. We have explained. This is not complete. Yes. The tool can't make sure when D equal to 7, there will be one item match it or not. Yes. So for this code, to make it complete, you have to write a default branch. You can assign some value here for default branch. Okay. Then this is complete, and this will synthesize to a combination logic. Okay. If you omit this line, then it will synthesize to latch. Okay, it will synthesize to latch with some combination logic. So always write a default branch and the last is a good coding style. Okay, but you can just take it easy. Or the coding problem, the link tool will check it and report it to you. Then you can modify your code. Okay. Okay, there is some idiot tool can check this for you. Okay, there is also case Z and case X in Verilog syntax. And my suggestion is you'd better avoid the use of case Z or case X. Okay, I will talk it in lecture 6. Okay, before going to the lecture slide, let's have a quick review of the basic elements in a module. How to write a Verilog module. Okay. Please take several seconds or 1 minute to take a look at the following code. Can you understand the meaning of the code? Okay, if you can understand the meaning of the code, and you can have the block diagram in your mind, I think you have mastered the syntax I have explained before. Okay, let's have a quick review. You have defined module name and list the I/O signals and define it here. Define the direction and signal type here. And also, if it's a multi-bit signal, you have defined the bitwise of each signal. Then there may be some internal signals. Yes, declare the internal signal with bitwise and type. Then within a module, you can instance some modules. You can instance some modules as your submodule. And you can have some statements. Yes, always block or continuous assignment block. And you have noted that for initial block, this is usually not used in synthesized code. Okay, for most of the case, or you can say for the case of ASIC, initial block is not synthesizable. Okay, it's only allowed at test bench. Okay, let's see. Using the syntax and the statement we have learned, can you make something valuable? Yeah, that is usable in a real chip design. So for this, I will make a 4-to-1 mux. I think this will be easy for you. Just take a look at the code segment and figure out the block diagram. Yes, note the default branch. This is to make sure the match item is complete. Yes. For this, you write this here to replace the default is also okay. This is the block diagram. Next, priority mux. Okay, the spec is the higher bits of D has higher priority. That is something like that. The block diagram, the truth table, you can say if bit 2 is 1, the output is always 2. Yes, it has higher priority. Then bit 1 has higher priority. The lower priority is bit 0. So this is the truth table and this is the block diagram. Can you write the actual code for this function? Okay, this is my answer. So for priority mux, we usually use if, else, if, else, if, else. Yeah. Okay, let's say the function of decoder. The spec is you can decode the n-bit input to nth power of 2 bits output. Usually the output is in the format of 1 hot or 1 cool encoding. So what is 1 hot? When you say these signals, these values, 1 hot means at the binary format there is 1 and only 1 bit is 1. All the other bits are 0. So this is called 1 hot. On the opposite is called one cool. That is, all the bits within all the bits there is only one bit is zero. Only one bit is zero, and all the other bits are one. This is called one cool. Okay, so this is the block diagram. Sorry, this is the IO define. Okay, you can say this is the IO define of this block, and this is truth table. Can you think out the actual code and the diagram of the circuit? If you use a math function, you can say the output equal to, yes, d in power of 2. Yeah, this is a function. This is a function in mathematics. So how to write this code? Yeah, this is something like that. You can use the case statement. Yes, list all the possible value of d in and give the correct output value for each match item. So this is the diagram of circuit. Okay, you have seen it before. This is simple. Okay, there is a little load. You can say the decoder, the mux, or you can say the mux here can also be used to select multi-bit data. Okay, you can use to select multi-bit data. Okay, and I want to introduce more for this. Okay, that is the else statement and the case statement can be listed. Okay, that means, let me demo it on this code. So for list, you can write something like that. For example, you can, if you want to give more statement for this match item, okay, you can give a begin end. Then you can use for example. Let's take it for example. Okay, let's just show you this. This is just to show you the syntax. Okay, make sure you have the else and the else branch. Yes, make this if else complete to avoid the latch. Okay, this is the list between case and if statement. Also, you can list. Okay, you can list case statement. Some signal we can use. Okay. Yeah. Yes. This is a list of case in case. Okay. For if else, you can also list if else else if. They can be listed as either format. Okay. They are very flexible. So you can still have if. Okay. Okay, this is an example. This is the listing of case if else if. Make sure they are complete. Okay. There is else paired with if, else paired with if. If you have more than one statement in a block, you have to use the begin end keyword. And make sure the case is complete. Okay. Write a default is a good coding style. Okay, for this case, if d equal to 1, this statement, all this statement in this begin end will be executed. Okay, that's all for this section. Thanks.